3. First, complete. If a equal 2 over 3, then a power minus 1. We have here a power minus 1. It will turn over the fraction. Then a equal 2 power 3. So a minus 1 power minus 1 will be equal 3 over 2. Okay? Example number 2, complete. 3 power 7 times 3 power minus 3. We have here 2 power and there is multiplication between them. Then when we add the power, okay? Then it will be 3 power 7 plus minus 3, which will be 3 power 4, okay? From the root of power. Thank you.
And now we will take definition of zero and the negative exponent or negative power. First, a to the 0 of power 1, a to the 0 of power 1, which is power of 0, which is a power of 0 equal 1. So any number or any sample raised to the power of 0 equal 1. Number 2, a to the power of minus n, a power of minus n, it will be reversed to a 1 over a power n. For example, we have 2 power of minus 1, it will be 1 over 2 minus power 1, which will be 1 over 2. Another example, a power n, it will be equal 1 over a minus n. For example, we have 2, which equal 1 over 2 minus 1. For example, here we have a power minus 2. Definition of negative exponent, it will be 1 over 3 power 2. Evaluate, then we will evaluate the exponent, it will be 1 over 9. Another example, minus 7 power 0. We said before, anything or any number it raised to the power of 0, it will be equal 1. Another example, 1 over 5 raised to the power of minus 2. From the definition of negative exponent, it will reverse the fraction, it will be 1 over 5 power 2, which equal 1 over 25, which equal, by simplifying, it will be 25. Another example, 0 power of minus 5, it can't be, so it will be undefined. Another example, evaluate the expression. We have 2 over 3 power of 0. As we said before, it will be equal 1. Minus 8 power of minus 2. From the negative exponent rule, it will be 1 over 64. Number 3, 1 over 2 power of minus 3. From negative exponent rule, it will be 1 over 8. And the negative power will reverse the fraction, it will be 8 over 1, which equal 8. Anything, number 4, anything power 0, it will be equal 1. Some properties of exponent: let a and b be a real number, and let m and n be integer. So if we have a power m times a power n, we will plus or summation the exponent. If we have power of power, it will be equal multiply of the two powers, so a power m power n, it will be a mn. If we have brackets and ab inside over raised to power m, it will be distribute the power for a and b, it will be equal a over m times p over m. A power m over a power n, the it will be minus, so it will be a m minus n. Last one, a over b, all of it raised to power m, it will be a over m, a power m over b power m. For example, we have here 6 power minus 4 times 6 power 4. We will plus or summation or add the power, it will be 6 power 0, which equal 1. Another example, power of power, we will multiply the two powers, it will be 4 power minus 4. Definition of negative exponent, it will be 1 over 4 power 4, which equal 1 over 256. Another example, 1 over 3 minus power minus 4, the same, it will be 81. Another example, we have here division, so we will subtract the power, then subtract, it will be minus 3. Negative exponent rule, it will be 1 over 5 power 3, which equal 1 over 125. Evaluate the expression, 1 over 4 power of 3, the same, 64, power of power equal 125. We will add power equal minus 3 power 0, which equal 1. Subtract the power and evaluate the value. Simplify the expression, write your answer using positive exponents. We will turn it to positive exponent. We have 2xy power of minus 5, all of it is raised to the power of 3. We will distribute the outer exponent. It will be 2 power 3 times x power 3 times y power of minus 5 power of 3. It will be like that. From the definition of negative exponent, it will be the simplest form equal 8x power 3 over y power 50. The same for this example. Simplest form. Practice here. The order of magnitude of the mass of polyphemus mouse larva when it hatches is 10 power minus 3 gram during the first 56 days of its life. The mouse larva can eat about 10 over 5 times its own mass in food. About how many grams of food can the mouse larva eat during the first 56 days? First, 10 power minus 15 gram. Second, 0.0000001 gram. C, 100 gram. D, 10 million gram. Solution. To find the amount of the food of the larva can eat in the first day, we have to multiply the original mass by 10 power 5. As we said before, it will be 10 over 2, 10 power 2, which equal 100. Then the result will be 100 gram of food. Another practice. sorry, continue the first example. So we have to find how many in 56 days